The bow section weighs 40 tons. It hangs from the USS Minneapolis by 2 inches of steel plating, twisted and bent at impossible angles. The metal screaming with every degree the ship rolls in the South Pacific swell. Inside the forward compartments, seawater rushes through gaps wide enough to walk through. The main deck buckles upward in a grotesque arch. 3 men are still inside, somewhere in the flooded darkness. It is 01:15 hours on November 30th, 1942. USS Minneapolis, a New Orleans-class heavy cruiser, displacing 9,950 tons standard and mounting 9 8-inch guns in 3 triple turrets, has just taken a Japanese Type 93 torpedo amidships on her port bow. The weapon, 24 inches in diameter, carrying 1,080 pounds of explosive, has detonated against her hull plating at the precise point where structural strength transitions from the heavily armored citadel to the lighter construction of the bow sections. The explosion vaporizes everything forward of frame 20. The ship's bow, from the waterline to the forecastle deck, simply ceases to exist as a coherent structure. Commander John Nathaniel Opie III, the ship's executive officer, reaches the forward damage control station at 01:17 hours. He finds Lieutenant Commander Harry Ellsworth Sauer, the first lieutenant and damage control officer, already directing teams into the wreckage. The forward fire room has flooded completely. The second fire room is taking water through fractured steam lines and buckled hull plating. Repair parties report the bow hanging by what they estimate as less than 3 inches of keel plating and the port side shell. The ship's forward motion through the water at 15 knots creates hydrodynamic forces that work against the remaining connections like a slow-motion guillotine. This is the Battle of Tassafaronga, a night surface engagement in Iron Bottom Sound between 8 American destroyers, 5 heavy cruisers, and 8 Japanese destroyers executing a supply run to Guadalcanal. The American force has radar. The Japanese have the Long Lance torpedo and 30 months of night combat training. In the next 20 minutes, American cruisers USS Northampton, USS New Orleans, and USS Pensacola will also take torpedo hits. Northampton will sink. New Orleans will lose her bow forward of turret 2. Pensacola will suffer catastrophic damage to her engineering spaces. Minneapolis will be the first hit. Captain Charles Edward Rosendahl, commanding officer of Minneapolis, faces a decision that will determine whether his ship survives the next 60 seconds. The bow section, still partially attached, creates enormous drag. Every mile of forward motion stresses the failing connection points. If the bow tears free while the ship maintains speed, the sudden release could cause the hull to whipsaw, potentially fracturing the keel or rupturing additional bulkheads, but stopping the ship in hostile waters, with Japanese destroyers still maneuvering nearby and the possibility of submarine contacts, transforms Minneapolis into a stationary target. Rosendahl orders all stop at 01:19 hours. The cruiser's momentum carries her forward for another 800 yards before she settles into the gentle swell, wallowing beam onto the seas. The bow section, no longer forced through the water, stops its terrible creaking. It hangs there, suspended, a 40-ton pendulum swinging with each roll of the hull. Below decks, damage control parties work in near-total darkness. The forward battle lanterns have shorted out. Portable emergency lights, rated for 20 hours of operation, throw inadequate pools of illumination across scenes of complete devastation. Watertight. Door 18-3-Quebec has been blown 15 feet inboard from its frame. The heavy steel door, designed to seal against flooding and maintain the ship's watertight integrity, now hangs from one hinge. Through the gap, the South Pacific pours into what remains of the bow structure at an estimated rate of 600 gallons per minute. Lieutenant Commander Sauer organizes teams to shore the bulkhead at frame 20. Navy doctrine calls for wooden shores, timber bracing wedged between bulkheads and decks to reinforce weakened structures. Minneapolis carries regulation damage control timbers, 4-inch by 4-inch Douglas, fir cut to standard lengths and stored in damage control lockers throughout the ship. The teams begin installing these shores at 01:25 hours. By 01:40 hours, they have placed 37 individual bracing timbers against the bulkhead at frame 20. The bulkhead continues to flex with each surge of water against it. Sauer reports to the bridge that the standard shores are insufficient. The forces acting on the damaged structure exceed anything the regulation bracing can handle. The USS Minneapolis belongs to the New Orleans class, authorized under the 1929 building program and laid down at the Philadelphia Navy Yard on June 27, 1930. Her keel consists of rolled steel plates, varying from 1 1/4 inches thick amidships to 7/8 of an inch at the extremities. Her frames, the transverse structural members that give the hull its shape, are spaced 24 inches apart and fabricated from angle iron and channels. The hull plating, riveted to these frames, ranges from 1/2 inch thickness at the waterline to 3/8 of an inch on the upper works. This construction, state of the art for 1930, provides excellent strength to weight ratio for a warship designed to make 32.7 knots on 107,000 shaft horsepower. It was not designed to maintain structural integrity with the forward 60 feet of ship reduced to scrap metal. Captain Rosendahl receives a report at 01:55 hours that 3 men remain unaccounted for in the flooded forward sections. Fireman First Class Robert Allen Morrison, Seaman Second Class James Patrick Donahue, Fireman Third Class William Henry Kozlowski. All 3 were on station in the forward fire room when the torpedo struck. Search parties have reached the fire room access, but the compartment has flooded to the overhead. The water, mixed with fuel oil from ruptured bunkers, makes visibility impossible even with battle lanterns. The compartment continues to flood. In 6 hours, when daylight arrives and Japanese aircraft can operate from their fields on Bougainville, Minneapolis will need to be somewhere else or hidden so effectively that aerial reconnaissance cannot locate her. The immediate crisis extends beyond the ship itself. Task Force 67, the American force that engaged the Japanese destroyers, has scattered. USS Honolulu and USS Helena, the 2 light cruisers, have reversed course to the southeast. The destroyers have begun searching for survivors from the stricken heavy cruisers. USS Northampton lists heavily to port, her engineering space is flooded, her power failing. She will capsize and sink at 0304 hours, taking 258 men with her. USS New Orleans, her bow sheared off at turret 2, navigates backward under her own power, the exposed forward bulkhead acting as a crude sea anchor. Pensacola burns from aviation fuel fires in her hangar spaces. Minneapolis has no power forward of the second fire room. Her forward 8-inch turret, Turret 1, has lost all connections to the magazine and handling rooms below. The turret itself, 60 tons of armor plate and weapons mechanisms, sits at an odd angle, canted 3 degrees to port as the deck beneath it has warped. Turret 2 and Turret 3, the wing and after turrets, remain operational, but the ship's main battery fire control, dependent on electrical systems routed through spaces now flooded or destroyed, has degraded to local control only. The 5-inch secondary battery, mounted in open mounts along the superstructure, can fire under local control, but coordination between mounts has become impossible. At 02:15 hours, the bridge receives a report from the after steering compartment, with the forward steering gear room flooded and power lost to the main steering station. The ship can only be controlled from the after steering position, a backup steering station located deep in the stern. This requires all helm orders to be passed by sound-powered telephone, a system of hardwired communications that requires no electrical power, but depends entirely on human operators relaying messages. The normal response time for helm orders increases from 2 seconds to potentially 15 or 20 seconds, depending on how quickly the telephone talkers can relay information through the chain. Commander Opie takes personal charge of the effort to stabilize the bow structure. He descends to the compartments immediately aft of the damage, where the bulkhead at frame 20 represents the only barrier between the flooded forward sections and the intact portions of the ship. The bulkhead, constructed of 1/4-inch steel plate reinforced with stiffeners, was never intended to serve as the ship's bow. Water pressure against it, estimated at over 6,000 pounds per square foot at the lower sections, causes visible deflection. The steel plate bows inward by as much as 4 inches at its center. The wooden shores, even 37 of them, cannot provide sufficient bracing. Opie makes a decision that exists nowhere in Navy damage control doctrine. He orders all available mattresses, bedding, mess tables, wooden benches, chairs, lockers, and any other movable wooden items brought forward and stacked against the bulkhead. Repair parties begin stripping berthing compartments, the crew's mess, the wardroom, anywhere they can find material. They create a chaotic pile of furniture and bedding, wedging it into place with the regulation 4x4 shores. The improvised bracing provides additional contact points, distributing the water pressure across more of the bulkhead surface. It is marginally better than nothing. It will not be enough. The Japanese Type 93 torpedo, called Long Lance by Allied intelligence, represents the most advanced torpedo in service with any navy in 1942, 49 feet 2 inches long, 24 inches in diameter. It carries its 1,080-pound warhead to a range of 43,000 yards at 48 knots, or 22,000 yards at 50 knots. The weapon runs on pure oxygen and kerosene, leaving no visible wake. American torpedoes of the same period, the Mark 15 surface-launched and Mark 14 submarine-launched, struggle with reliability problems, defective depth-keeping mechanisms, and magnetic exploders that frequently fail to detonate. The Type 93 works. At Tassafaronga, Japanese destroyers launched what American analysis would later estimate as 24 to 28 torpedoes in a coordinated spread. 5 found targets. By 0300 hours. Captain Rosendahl has a navigational problem that supersedes all others. Minneapolis sits 28 nautical miles northwest of Lunga Point, Guadalcanal, in waters the Navy has designated as contested. Japanese submarines patrol these approaches regularly. Japanese aircraft from Rabaul and Bougainville can reach this position with ease. The nearest friendly port capable of receiving a damaged heavy cruiser is Espiritu Santo in the New Hebrides, 640 nautical miles to the southeast. Tulagi, the small harbor across from Guadalcanal where American PT boats operate, lies 42 nautical miles to the southeast. Tulagi has no repair facilities, no machine shops, no dry dock. Nothing but a small anchorage protected by terrain and whatever air cover can be provided by the fighters operating from Henderson Field on Guadalcanal. Rosendahl chooses Tulagi, the alternative, attempting the 640-mile voyage to Espiritu Santo with a bow hanging by fragments of hull plating and a temporary bulkhead reinforced with mattresses and mess furniture. Offers a probability of success that no one aboard ship can calculate, but everyone understands to be minimal. Getting to Tulagi requires 42 miles of careful navigation, towing the bow section or cutting it free, and arriving before daylight makes the ship visible to Japanese reconnaissance. At 0320 hours, Commander Opie reports that 3 damage control parties have entered the flooded forward fire room using underwater breathing apparatus. The Mark IV submarine escape apparatus, called the Momsen lung after its inventor, provides approximately 8 minutes of breathing time in flooded compartments. The parties search systematically, working in zero visibility through water contaminated with fuel oil and debris. At 0341 hours, they locate Fireman First Class Morrison's body wedged against a steam valve manifold. At 0355 hours, they find Seaman Donahue trapped beneath a collapsed section of deck plating. Fireman Kozlowski remains missing. The search parties withdraw at 0405 hours, their Momsen lungs depleted, reporting they cannot continue without additional equipment and better visibility. The sky begins to lighten at 0515 hours. In 2 hours, Japanese float planes from their base at Shortland Harbor will begin reconnaissance sweeps of Iron Bottom Sound and the waters around Guadalcanal. These aircraft, primarily Kawanishi Type 0 reconnaissance seaplanes and Aichi Type 0 reconnaissance seaplanes, have spotted every major American ship movement in the Solomons since August. They operate beyond the effective range of American fighters from Henderson Field and report directly to Rabaul, where Japanese bombers can launch strikes within 2 hours of receiving targeting information. Captain Rosendahl orders the bow section cut free at 0530 hours. The ship's metalworkers, using acetylene cutting torches, begin severing the remaining connections between the bow and the hull. The work requires 40 minutes of careful cutting, with teams positioned to control the separation and prevent the heavy bow section from damaging additional hull plating as it tears away. At 0612 hours, the final connection parts, the bow section, 40 tons of twisted steel, drops away and sinks in 240 fathoms of water. Minneapolis now terminates at frame 20, her hull ending in a flat vertical surface that was never meant to face the sea. The temporary bulkhead, reinforced with mattresses and furniture and 37 wooden shores, becomes the ship's bow. Commander Opie surveys the result and concludes that making way through the water at any speed above 3 knots will likely cause the bulkhead to fail catastrophically. The ship needs additional reinforcement, something stronger than mattresses, more substantial than 4x4 timbers. She needs this reinforcement immediately, before attempting the 42-mile voyage to Tulagi. At 0630 hours, lookouts report land bearing 090 degrees true. Distance approximately 12 miles. This is Guadalcanal, specifically the coastline east of Lunga Point, where the island's interior mountains descend to narrow coastal plains covered in jungle. Captain Rosendahl makes his second critical decision of the morning. He orders Minneapolis to close the coast and anchor in the shallows under cover of the jungle canopy. The cruiser approaches the coast at 4 knots, her forward bulkhead flexing with each slight increase in speed. At 07:45 hours, with the water depth decreasing to 12 fathoms, Rosendahl orders anchors dropped. Minneapolis settles stern first into position approximately 800 yards offshore, her damaged bow pointing toward the beach, her stern toward open water for a quick departure if needed. The jungle rises behind her. Coconut palms and banyan trees and dense tropical vegetation extending up the slopes of the coastal mountains. From the air, Rosendahl calculates, the ship's gray camouflage scheme might blend with the shadows under the trees. It might not. Japanese pilots have excellent vision and considerable experience spotting camouflaged positions. Lieutenant Commander Sauer proposes a solution at 0800 hours. The crew will camouflage the entire ship using cut vegetation from the jungle. They will land parties on the beach, cut palm fronds and tree branches, transport them back to the ship, and cover every horizontal and vertical surface. From the air, Minneapolis will appear to be nothing more than an extension of the jungle itself, a dark green mass of vegetation indistinguishable from the surrounding forest. The evolution begins at 0815 hours. Motor whaleboat number 1 and motor whaleboat number 2, each powered by a small gasoline engine and capable of carrying 12 men plus equipment, make runs to the beach. Shore parties, armed with machetes, axes, and handsaws from the ship's damage control stores, wade into the jungle and begin cutting. They quickly discover that coconut palm fronds, which can reach 12 feet in length and 4 feet in width, make ideal camouflage material. The fronds are light enough to handle easily, but large enough to cover significant areas. A single coconut palm, properly harvested, can yield 15 to 20 usable fronds. By 0930 hours, the first boatloads of cut vegetation arrive back at the ship. Crew members stationed along the rails haul the fronds aboard and begin draping them across the gun mounts, the superstructure, the boat deck, anywhere that might catch the sun and create shadows or highlights visible from above. The work continues throughout the morning. Additional shore parties deploy to cut more material. By 1100 hours, Minneapolis has nearly disappeared beneath a covering of green vegetation. Only her masts and uptakes, too tall to effectively camouflage, remain visible. Sauer orders these painted with whatever green paint the ship carries. The painters mix standard Navy deck gray with the limited supplies of green tint available in the paint locker, producing a muddy olive color that approximates jungle foliage at a distance. The camouflage addresses one problem, while the more critical structural issue remains unsolved. Commander Opie examines the bulkhead at frame 20 throughout the morning, monitoring its condition as the ship rises and falls gently in the anchorage. The bulkhead continues to flex. The mattresses and furniture, compressed by water pressure and their own weight, have compacted into a sodden mass that provides some bracing but not enough. Opie needs something rigid, something that can resist compression, something available in quantity on a jungle island with no port facilities, no lumber yard, no construction materials of any kind. At 12:15 hours, a sailor from one of the shore parties returns with a section of coconut palm trunk, cut from a fallen tree. The trunk, approximately 18 inches in diameter and 6 feet long, consists of extremely dense fiber surrounding a softer core. The sailor has brought it aboard as a curiosity, showing how the dense outer layer resists machete strikes. Opie examines the trunk section. He tests its compressive strength by standing on it, then having additional men stand on it. The trunk compresses slightly but maintains its structural integrity. He performs a rough calculation based on the trunk's diameter, the bulkhead surface area, and the estimated water pressure. Then he orders the shore parties to begin cutting coconut palm logs. The coconut palm, Cocos nucifera, grows throughout the tropical Pacific. The trees reach heights of 60 to 100 feet and develop trunks up to 18 inches in diameter. The trunk consists of a fibrous outer layer approximately 2 to 3 inches thick surrounding a softer pithy core. This structure gives the palm considerable flexibility in high winds, but also provides surprising compressive strength. The fiber aligns vertically along the trunk, creating natural reinforcement against longitudinal loads. A coconut palm trunk 18 inches in diameter can support loads exceeding 10,000 pounds before failure. Shore parties begin felling coconut palms at 1300 hours. The work requires considerable effort. Coconut palms do not have conventional bark or growth rings. The trunk's fibrous construction resists cutting. A single palm requires 30 to 40 minutes of axe work to fell, then additional time to strip the fronds and cut the trunk into manageable sections. The parties target palms growing close to the waterline, where the boat crews can extract the cut logs without hauling them through dense jungle. By 1500 hours, they have felled 12 palms and cut them into sections ranging from 6 to 10 feet in length. Transport presents the next challenge. Coconut palm wood, despite its fibrous nature, has a specific gravity of approximately 0.65, making it buoyant in seawater. The boat crews lash the log sections together in rafts of 4 to 6 logs and tow these rafts to the ship. By 1600 hours, 24 coconut palm logs have been brought aboard and lowered into the compartments adjacent to the damaged bulkhead. Commander Opie supervises the installation personally. The logs, cut to lengths that fit precisely between the bulkhead and the next transverse bulkhead frame aftee, are wedged into place vertically. The standard 4x4 Douglas fir shores, originally placed at 37 locations, are repositioned to wedge the coconut logs tight against both bulkheads. The result creates a compression structure where the water pressure pushing against the forward bulkhead is resisted by the coconut logs, which transfer the load to the bulkhead aftee, which is backed by intact hull structure. Additional logs are placed horizontally where space permits, creating a lattice of natural timber that reinforces the damaged area from deck to keel. By 1800 hours, 48 coconut palm log sections have been installed. The bulkhead deflection, previously measured at 4 inches at its center, has decreased to approximately 1 inch. Opie orders sound-powered phone talkers to monitor the bulkhead condition continuously and report any changes. The temporary reinforcement, created from materials cut from the jungle 800 yards away, has transformed a failing emergency bulkhead into something that might survive a voyage under power. At 1830 hours, lookouts report aircraft approaching from the northwest. 2 single-engine aircraft, identified as Japanese float planes, conduct a systematic search pattern over Iron Bottom Sound. The aircraft fly at approximately 3,000 feet, following a standard reconnaissance pattern that will bring them within 5 miles of Minneapolis's anchorage. Captain Rosendahl orders absolute silence and no movement on deck. The crew, already wearing green vegetation as improvised camouflage on their helmets and life jackets, freeze in place. The ship sits motionless beneath her covering of palm fronds, stern anchored, bow pointing toward the beach. Appearing from above is nothing more than a dark mass beneath the jungle canopy. The float planes pass 4 miles to the west at 1845 hours, continuing their search pattern toward Cape Esperance. They do not deviate from their course. The camouflage has worked, or the pilots have failed to look in the right direction at the right moment, or the ship's position in the coastal shadows has made her invisible. The aircraft depart to the northwest at 1900 hours. Rosendahl orders preparations to get underway. The engineering department reports readiness at 1930 hours. The second fire room and the 2 after fire rooms remain operational. The ship can make steam for approximately 20 knots, limited not by boiler capacity, but by structural concerns about the forces acting on the temporary bow bulkhead. Chief Engineer Commander Roland William Webb recommends no more than 5 knots until the bulkhead's performance underway can be evaluated. Rosendahl concurs. At 2000 hours, Minneapolis weighs anchor and begins backing away from the coast. The maneuver requires careful coordination through the after-steering position. The helmsman, receiving orders by sound-powered phone from the bridge, turns the ship's stern first until her bow points southeast toward Tulagi. At 2015 hours, the engines answer ahead slow. The cruiser begins moving forward at approximately 3 knots. The bulkhead at frame 20 flexes but holds. By 2030 hours, Minneapolis has cleared the coastal anchorage and entered open water. The voyage to Tulagi requires 14 hours at 3 knots. Captain Rosendahl stations additional lookouts and orders the crew to battle stations. The ship proceeds darkened, showing no lights, her camouflage of palm fronds still draped across her superstructure and gun mounts. In the forward compartments, repair parties monitor the coconut log bracing continuously, checking for compression, movement, or failure. The logs hold. The bulkhead continues to flex with the rhythm of the ship moving through the gentle swell, but the deflection remains constant at approximately 1 inch. At 0200 hours on December 1st, lookouts report green flares bearing 110 degrees true. Distance approximately 8 miles. These flares mark the entrance to Tulagi Harbor, set by PT boat crews to guide friendly vessels. Minneapolis alters course to close the markers at 03:45 hours. She enters Tulagi Harbor and anchors in 18 fathoms. The voyage from the camouflage anchorage has taken 7 hours, 45 minutes and covered 42 nautical miles. The temporary bulkhead reinforced with coconut palm logs has survived. Tulagi offers nothing resembling repair facilities. The harbor consists of a natural anchorage between Tulagi Island and the smaller Florida island, protected from the open sea but exposed to air attack. American forces maintain a seaplane base on Tulagi and PT boat operations from a small base at Sasapi. The base has a radio station, fuel storage for the PT boats, ammunition storage, and a small medical facility. It has no dry dock, no machine shops beyond basic PT boat maintenance capabilities, no welding equipment suitable for ship hull repairs, no construction materials, and no spare parts for cruiser systems. It has coconut palms. Lieutenant Commander Sauer surveys the anchorage at first light on December 1st and concludes that Minneapolis can survive here for several days while the crew strengthens the temporary bulkhead and prepares the ship for the voyage to Espiritu Santo. The primary requirement remains additional bracing material. The 48 coconut logs installed during the initial emergency have compressed slightly under load. Additional logs, installed to distribute the load across more contact points, will reduce stress on individual logs and provide redundancy if any single log fails. Shore parties deployed to Tulagi and Florida Islands throughout December 1st and 2nd. They fell every accessible coconut palm within reasonable distance of the waterline. The logs, cut into standardized lengths of 8 feet, are rafted to the ship and installed in the forward compartments. By December 3rd, 127 coconut palm logs brace the bulkhead at frame 20. The compartment resembles a timber crib, a dense lattice of vertical and horizontal logs wedged between bulkheads from the keel to the second deck. The additional bracing reduces bulkhead deflection to less than ½ an inch. The crew also addresses the ship's other battle damage. Electricians' mates reroute power cables around flooded compartments, restoring electrical power to turret 1 and the forward 5-inch mounts. Machinists fabricate replacement parts for damaged pumps and valve assemblies. Damage control parties patch smaller hull fractures using collision mats and cement boxes. Temporary repairs that reduce flooding in previously inaccessible spaces. The ship's carpenter shop produces wooden forms that are installed against hull breaches, then backed with concrete mixed from cement stored in the ship's damage control supplies. These concrete patches, reinforced with steel rods salvaged from wrecked internal structures, provide watertight integrity sufficient for a passage to a repair facility. On December 4th, divers from the PT boat base conduct an external survey of Minneapolis's hull. They report that the keel appears intact aft of the damage, with no visible cracks or deformation. The hull plating, despite the violence of the torpedo detonation and the stress of towing 40 tons of hanging bow structure for nearly 2 hours, shows no additional fractures beyond the immediate blast area. The ship's longitudinal strength, the structural characteristic that prevents the hull from breaking in half under stress, has survived. This assessment gives Captain Rosendahl confidence that Minneapolis can make the voyage to Espiritu Santo. The Navy dispatches fleet tug USS Navajo to escort Minneapolis to Espiritu Santo. Navajo, a Cherokee-class tug displacing 1,470 tons and capable of making 16 knots, carries heavy towing gear and additional damage control equipment. She arrives at Tulagi on December 6th and moors alongside Minneapolis to transfer equipment and coordinate the passage. The tug's commanding officer, Lieutenant Commander Hugh William Hadley, surveys the cruiser's damage and examines the coconut log bracing. He reports to his superiors that the temporary repair represents the most innovative damage control work he has encountered in 20 years of naval service. He also notes that it exists nowhere in Navy regulations or damage control manuals. Minneapolis departs Tulagi on December 9th at 0800 hours, escorted by Navajo and 2 destroyers. The voyage to Espiritu Santo, 640 nautical miles southeast, requires approximately 6 days at the planned speed of 5 knots. Captain Rosendahl orders the crew to maintain continuous monitoring of the bulkhead condition, the coconut log bracing, and the temporary concrete patches. The first 24 hours of the voyage will determine whether the repairs can survive sustained operations at sea. The ship encounters moderate seas on December 10th, with swells reaching 6 to 8 feet. The motion causes the bulkhead to flex rhythmically, the deflection varying between 1/4 inch and 3/4 of an inch as the bow rises and falls. The coconut logs compress and expand slightly with each cycle, absorbing energy and distributing loads. Several logs develop longitudinal cracks after 18 hours of this cycling, but the cracks do not propagate through the full diameter. The logs continue to function. Commander Opie orders damage control parties to monitor the cracked logs hourly and prepare replacement logs from the ship's remaining supply of cut timber. On December 11th, the weather deteriorates. Wind increases to 25 knots from the southeast, generating seas of 10 to 12 feet. Minneapolis's blunt bow, the flat vertical surface of the frame 20 bulkhead, pounds into the swells with jarring impacts. Each impact transmits shock through the coconut log bracing. Captain Rosendahl reduces speed to 3 knots. The reduced speed decreases pounding, but extends the voyage by 2 days. The calculation is simple. Arrive slowly or risk catastrophic bulkhead failure and sink quickly. By December 13th, the weather moderates. Minneapolis resumes 5-knot speed and continues southeast. The coconut log bracing, subjected to 4 days of continuous stress cycling, shows signs of fatigue. Approximately 30 logs have developed cracks. 6 logs have compressed to the point where they no longer maintain firm contact with both bulkheads. Damage control parties replace these 6 logs with spare logs cut at Tulagi, using the ship's carpenter shop to fabricate wedges that maintain compression on the replacement timber. USS Minneapolis enters Espiritu Santo Harbor on December 15th at 14:30 hours. The voyage from Tulagi has required 6 days, 6 hours, and covered 643 nautical miles. The temporary bulkhead, reinforced with 127 coconut palm logs cut from the jungles of Guadalcanal and Tulagi, has survived 12 days of continuous service under conditions that exceeded any damage control scenario in Navy planning. Espiritu Santo maintains the fleet repair anchorage for the South Pacific. The base has floating dry dock ABSD-1, a section of which can accommodate cruisers, destroyer tenders with full machine shops, ammunition ships, stores ships, and a permanent base force of several thousand personnel. Minneapolis enters dry dock on December 17th. As the dock pumps out and the ship settles onto the blocks, Navy inspectors examine the damage for the first time under controlled conditions. The inspection report, filed on December 19th, documents the extent of the torpedo damage and the improvised repairs. The torpedo detonation fractured the keel between frame 13 and frame 21, demolished all internal structure forward of frame 20, and created hull breaches extending from the keel to the main deck on both port and starboard sides. The temporary bulkhead at frame 20, classified as a 1/4-inch steel collision bulkhead in the ship's construction plans, shows permanent deformation of 6 inches at its center, despite the coconut log bracing. The concrete patches applied at Tulagi have held, though several show cracks in one has partially separated from the hull plating. The coconut palm logs receive particular attention in the inspection report. Of the 127 logs installed, 93 show longitudinal cracks ranging from superficial surface splits to cracks extending through 60% of the log diameter. 34 logs remain structurally sound. All logs show compression damage where they contact the bulkheads and the wooden shore timbers. The dense fibrous structure of the palm wood has prevented catastrophic failure even in heavily damaged logs. The inspection team calculates that the coconut log bracing absorbed approximately 40% of the water pressure loads on the bulkhead, with the remaining 60% borne by the bulkhead steel itself and the secondary bracing of mattresses, furniture, and regulation damage control timbers. The report concludes that without the coconut log reinforcement, the temporary bulkhead would have failed during the voyage from the camouflage anchorage to Tulagi. The bulkhead would certainly have failed during the passage from Tulagi to Espiritu Santo. Minneapolis would have flooded progressively from the bow aft, overwhelming the pumping capacity and eventually sinking the ship. The improvised damage control measures, particularly the use of locally sourced coconut palm timber, saved the vessel. Permanent repairs to Minneapolis require 3 months. Navy construction battalions fabricate a new bow section at Espiritu Santo using steel plate and structural members brought from the United States. The new bow, built to a slightly modified design that incorporates lessons from the torpedo damage, extends to frame 18, 2 frames shorter than the original construction. This modification reduces the ship's length by 8 feet, but maintains her seagoing characteristics and weapon systems. The new bow section weighs 38 tons, 2 tons less than the original. and includes additional watertight subdivisions to limit flooding and future damage scenarios. Installation of the new bow begins on January 20th, 1943. The work requires removing all damaged structure forward of frame 21, cutting the keel and hull plating to create clean joining surfaces, then welding the new bow section in place. Navy welders work in shifts around the clock, laying thousands of feet of weld bead to join the new construction to the existing hull. The final structural welds are completed on February 8th. Hydraulic and electrical systems installation requires an additional 3 weeks. Hull painting, final equipment testing, and crew training exercises extend the timeline to mid-March. USS Minneapolis departs Espiritu Santo on March 18, 1943, proceeding to Pearl Harbor for additional work. She arrives at Pearl on March 27th and enters dry dock for final inspections and corrections to the Espiritu Santo repairs. The Pearl Harbor team replaces some of the Espiritu Santo welds, which showed defects from working in field conditions, and upgrades some of the hastily installed equipment. Minneapolis leaves Pearl on May 20th, proceeding to Mare Island Navy Yard in California for a complete overhaul that includes installation of improved radar, additional anti-aircraft guns, and replacement of battle-worn machinery throughout the ship. She returns to combat operations in August 1943, joining the Fast Carrier Task Forces for operations against Japanese-held islands in the Central Pacific. Over the next 2 years, Minneapolis participates in the Gilbert Islands Campaign, the Marshall Islands Campaign, the Marianas Campaign, and the Philippines Campaign. She provides naval gunfire support for amphibious landings, screens carriers against air attack, and engages Japanese surface forces in night actions. She survives the war without additional serious damage. The coconut log damage control technique does not enter Navy damage control doctrine. The circumstances that made it necessary, a heavy cruiser with catastrophic bow damage requiring repair using only materials available on a jungle island with no facilities, are too specific for general application. But word of the Minneapolis repair spreads through the fleet. Damage control officers, always seeking methods to save ships under emergency conditions, study what Commander Opie and Lieutenant Commander Sauer accomplished with improvised materials and aggressive action. The Battle of Tassafaronga generates extensive analysis in post-war years. The engagement, a tactical defeat for the United States Navy despite overwhelming numerical and technological advantages, reveals critical deficiencies in doctrine and training. American forces had radar, which should have provided decisive advantage in night combat. Japanese forces had superior torpedo armament and years of training in night surface action. The result was 4 American cruisers damaged, 1 sunk, and the Japanese supply run to Guadalcanal barely interrupted. The Navy's surface warfare community studies Tassafaronga intensively, incorporating lessons about night combat tactics, radar employment, and torpedo defense into revised doctrine. But the larger lesson, the one that Minneapolis embodies, concerns adaptability and resourcefulness in crisis. Commander John Opie did not consult a manual when he decided to use coconut palm logs as structural bracing. No manual covered the situation. He evaluated the problem, identified a resource, tested it under conditions that approximated the actual loads, and implemented a solution. He did this while his ship sat damaged in hostile waters with Japanese aircraft operating overhead. The entire evolution, from first cutting coconut palms at the camouflage anchorage to installing 127 logs at Tulagi, required 4 days. It saved a 9,000-ton heavy cruiser. Fireman 3rd Class William Henry Kozlowski's body was never recovered. Search operations at the camouflage anchorage on December 1st located his remains in the collapsed forward fire room, but conditions made recovery impossible. His name appears on the tablets of the missing at the Manila American Cemetery in the Philippines. Morrison and Donahue were buried at sea on December 1st with full military honors. Their bodies committed to the same waters where Minneapolis nearly followed them. USS Minneapolis was decommissioned on February 10th, 1946 at the Philadelphia Navy Yard, the same facility where she had been built 16 years earlier. She was sold for scrap on August 23rd, 1946. The coconut palm logs that saved her ended their service at Espiritu Santo, removed during the permanent bow installation and burned as the work progressed. No one thought to preserve them. They were improvised materials pressed into service during an emergency, not relics worthy of museums. They had done their job. The ship's bell was preserved and presented to the city of Minneapolis, Minnesota. It sits in a display case at the Minneapolis City Hall. a piece of bronze weighing 47 pounds, inscribed with the ship's name and commissioning date. Visitors pass it daily without knowing the story of the jungle anchorage. The palm frond camouflage. The shore parties cutting logs in the heat while Japanese float planes searched overhead. The 6-day voyage to safety on a bow held together with tropical timber. The bell endures. The story, like so many from that war, exists in official reports and fading memories, and the fact that USS Minneapolis survived when by all reasonable expectations she should have sunk. That is the measure of damage control, not the equipment carried or the procedures practiced, but the willingness of men in crisis to find solutions in the materials at hand and execute those solutions while their ship settles lower in the water and the enemy searches for them from above. Commander Opie and his teams cut down a forest and built a bow from it. The bow held, the ship lived. Everything else follows from that.